Alright, let's take a look at example 33a. Now you're given this equation in this form. Alright, the argument of z minus 1 plus 2i is equals to pi over 3. Yeah, so pi over 3 is 60 degrees. Right. So how do we actually draw the locus, the half line represented by this equation? Alright, so first and foremost, alright, so let's take a look at the standard form of the way we write the equation of the half line. Okay, so let's do a quick recap. The standard form is actually written as argument of the variable complex number z minus p plus iq, alright, equals to a certain theta, right? And your z here represent the point P, is represented by the point P, whereas the fixed complex number p plus iq is represented by the point A. And then we also talk about how this is analogous to the argument of the vector AP, alright, equals to theta. Alright, so the locus of this particular example, after we have written it in standard form, this is what you're going to see. Right, so this is what you have just seen. Right. So what it means is, in this case, alright, again let me just write it out for you. Z, the complex number, is represented by the point P, and 1 minus 2i is represented at the point A. Okay, so the first thing that we need to do is, of course, mark out where is the point A. So let's go and mark the point A. You have the imaginary axis, you have the real axis. Right, the point A is 1, negative 2, so 1 and negative 2, and the point A is here. Alright, so A is 1, negative 2. Now after you have marked out the point A, you draw a horizontal line from A, alright, in the positive direction. Alright, you draw a small circle at A because the locus representing the half line does not include the point A itself. So that is why we put a circle at the point A. Right, so from the point A, what you're going to do is, if you look at the way that we look at the vector representation of this AP, right, down here, alright, it is as if you are saying that the argument of the vector AP is theta, meaning to say we are actually looking at what angle the vector AP makes with the positive horizontal. Alright, now P being the variable complex number must lie on this half line. So, right, I'm going to draw a line from A such that, okay, all the points on this line are actually the possible places where the complex number can be represented by. Alright, the complex number Z can be represented by. So I must make sure that the angle that this line makes, alright, is actually, in this case, pi over 3. Alright, now because if you look at the angle represented here, the argument represented is plus pi over 3, so when you measure from the horizontal, you're going to measure it anti-clockwise, because that will give you the positive argument. Right, so what it means is this: the locus of the complex number Z are all the points on this line starting from A and continue infinitely to infinity. alright, but it does not include the point A itself. So if you were to look at the way we define it in terms of a vector, alright, so we are as if saying that the argument of the vector AP, alright, is pi over 3, and you know that A is here and P are all the points on this line. So AP, alright, forms an angle of pi over 3. Alright, let's take a look at the second example, example 33b. Alright, so the equation given is as so. Alright, so the locus of the half line given, okay, we need to actually write it out in the standard form. So the standard form is this, right? So we do take note that the variable complex number z is represented by the point P again as always, and then the fixed complex number 1 minus 2i is represented by the point A. So if we look at the analogy of the vector, so it's as if we are looking at the argument of the vector AP. So if we look at the analogy of the vector, so it's as if that we are looking at the argument of the vector AP being negative pi over 6. In essence, we are actually measuring the angle that AP makes with the positive horizontal, and in this case is negative pi over 6, which tend to tell you that the argument measured must be in the clockwise direction, because that will give you the negative value. Okay, so first thing you need to do is of course mark the point A. So let's go and mark the point A. So you have the imaginary, you have the real, and the point A. 1, negative 2. So this is the point A. Alright, so 1, negative 2. Making sure that there's a small circle at the point A, because for the half line, again let me repeat, the locus of the variable complex number z does not include the point A itself. On that note, do you know why? Go and think. Right, so you draw the horizontal line, and then it says here that the argument is negative pi over 6, so you're going to measure it in clockwise direction. Right, and that argument is given as negative pi over 6. Okay, so the locus of the variable complex number z are all those points, okay, on this line here. And of course, the question actually asks you to describe this half line geometrically. So the way that you describe it is what you see, which is printed there. Right, but making sure that you realize that one thing which is very crucial for you to take note of, that it does not include the point A itself. Okay, let's look at example 33c. Alright, so we're supposed to draw the half line, but oh no, this is a form which you have never seen before. So what you need to do is rewrite it in the standard form. And let me just maybe quickly write what is the standard form again for you, which is argument of z minus p plus iq equals to theta. Right, so we realize that in this question the coefficient of z is 2. Alright, and then in the denominator, okay, you have another complex number. So what we need to do is actually get rid of this. Alright, and in the best way possible is to make use of the properties of argument. Right, so the properties of argument says that we can actually do this. Okay, which property is it? The argument of So implementing the properties of argument, you will be able to arrive to this standard form. Alright, to this standard form. And again, therefore, we are looking at argument, alright, of the z represented by the point P, half represented by the point A. So it's as if that we are looking at what angle does the vector AP makes with the positive horizontal, and in this case it's actually negative 2 pi over 3. Alright, so as usual, we go and mark the point A first. Right, the point A is half, so let's say half is here, right, and that's point A. Okay. Draw your horizontal dotted line in the positive direction, and the angle that it makes with this positive horizontal is negative 2 pi over 3, which is negative 120 degrees, which is about here. Right, so this argument is negative 2 pi over 3. Alright, so there you go. You are done with the drawing of this locus. And to describe it geometrically, this is what you see printed here. Right, making sure again that your locus, the half line here, does not include the point A.